All right, next in the unit, we're going to be doing applications of rational functions. And the most common application type of problem that I've seen is rate of work. And it's not that there aren't other problems that we will do other types of problems, but as far as the EOC goes, rate of work problems are the ones that I've seen the most consistently. So that's what we're going to focus on the most. And then certainly we're going to work on the other ones, but those seem to be less common. So rate of work problems usually involve two people, maybe more, who are trying to help each other finish a single job, and the two people involved work at different rates. So for example, we have Fran who can clean the garage in 3 hours, and we have Angie who can clean the garage in 4 hours, and they're going to work together to clean the garage. How long would it take them to clean the garage working together? So we're going to kind of work our way through this. If it takes Fran 3 hours to do the whole job, then that means that in 1 hour, she would be able to do 1/3 of the job. If it takes Angie 4 hours to do the whole job, then in 1 hour, she could do 1/4 of the job. So if X represents how many hours it would take both girls to do the whole job together, then in 1 hour, they could do 1/X of the entire job. So what we'll say is that if we have Fran's contribution is 1/3 and Angie's contribution is 1/4, that's going to equal 1/X altogether. So what we're going to do is we're going to go ahead and solve for X, and we're going to use the methods that we've learned in solving our rational equations. So we learned when solving rational equations to look for the least common denominator, which in this case is just going to be 12x. 3 times 4, 12, and then x. So we're going to multiply the entire equation by 12x, and we get 1/3 times 12x plus 1/4 times 12x equals 1/x times 12x. So that gives us 4x plus 3x equals 12. So 7x equals 12. X equals 12/7. Now, if you asked me, hey, there's 2 girls cleaning the garage together, how long is it going to take them? And I said 12/7, that would be a ludicrous answer to the question. So most people would want to know in terms of hours and minutes, or at least a decimal answer. So 12 divided by 7 is approximately 1.714, a little over an hour and a half. So I'm just going to say 1.714 hours and call that a good answer. And we know that since these are story problems, story answers make more sense. I'm not going to write sentences in this video just to keep the video a little bit shorter. Okay, so just to kind of make this next example to clean up, kind of make the process of going through this a little bit shorter, I'm going to kind of walk through it again, but condense it a little bit. So here we have Kent and Kendra, and they're going to be painting. Kent can paint the room in 6 hours, so he can do 1/6 of the room in 1 hour. Kendra needs 4 hours to paint the same room, so she can do 1/4 of the room in 1 hour. So we're going to say that they can do 1/6 plus 1/4 is going to give them 1/x of the room in 1 hour. So we're going to multiply this by the least common denominator. The least common denominator would be 24x. And so we're going to multiply the entire equation by 24x. So 1/6 times 24x plus 1/4 times 24x equals 1/x times 24x. That gives us 24 divided by 6 is 4x. 24 divided by 4 is 6x. 24. And so I'll divide by 10, divide by 10. So 2.4 hours is how long it would take them to paint the room if they were painting the room together, if we need them. And then the last type of problem, we're also going to make sure to practice. These are, we're going to call them with or against problems, with or against the wind, with or against the current if we're talking about water. So the example we're doing here, and it compares speeds when you're moving with, I wrote without and without. It's comparing speeds when you're moving with and without resistance. So you're moving with the wind or against the wind, with the current or against the current. I'm sorry if that was redundant. I got I got distracted in the confusion of what I was writing there. This is the first version of these notes, so there might be some typos. All right, so for example, Garth can row 5 miles per hour in still water. It takes him as long to row 4 miles upstream as 16 miles downstream. How fast is the current? So these are some variations of common formulas that we're going to work with. The primary formula is distance is rate times time. So by manipulating different variables, you can get rate isolated. So rate would be distance divided by time. Time would be the distance divided by the rate. So there's different ways you can isolate these different formulas. Here we're going to say that our x represents the speed and the water because this first version is not dealing with wind resistance, it's dealing with the resistance from the current of the water. So x is going to represent the speed in still water, and c is going to represent the speed in the current. So when you are moving upstream, you are taking the speed in the still water and you are subtracting from that speed the resistance that you're getting from the current, so it's slowing you down some. When you're moving downstream, you are adding to that the speed of the current because it's making you move faster, it's pushing you along. So that's kind of how the rate is being affected. So we're going to fill in this table with some information. We're going to plug in the distance, we're going to plug in the rate, we're going to figure out the time. All right. So for this problem, we have our speed in still water, which was 5. So our x is going to be 5. So we're going to have 5 minus c, 5 plus c. The distance upstream was 4. The distance downstream was 16. And then the formula for time is distance divided by rate. So we're going to say 4 divided by 5 minus c, 16 divided by 5 plus c. Now, in the problem it said it takes him as long to row 4 miles upstream as 16 miles downstream. So that means that those two times are actually equivalent. So this time and this time are the same as each other, which means that we have an equation that we can solve. So we have a fraction equals a fraction. And what that means is that we can cross multiply to solve this problem. So we're going to multiply these two together. I'm going to get 16 times 5 minus c equals, and I'm going to multiply these two together. 4 times 5 plus c. And then I can go through and solve this equation. So I'll distribute the 16, 80 minus 16c equals 20 plus 4c. I'll go ahead and add the 16c to the other side. 80 equals 20 plus 20c. I'll subtract the 20. 60 equals 20c. Go ahead and divide the 20 on each side. 3 equals c. So what that means is that the speed of the current, how fast is the current? The current is 3 miles per hour. The current is 3 miles per hour. All right, now they'll switch around some of the different things that you're trying to find in these problems. So for example, in the next problem, a boat goes 240 miles downstream, okay, in the same time that it takes to go 160 miles upstream, all right? The rate of the speed of the current is 5 miles per hour. So this time, instead of knowing the speed in still water, we know the speed of the current. So it's going to say x minus 5, x plus 5. So instead of solving for the current, we're solving for the speed of the still water. So here, I'm going to say 160 over x minus 5, 240 over x plus 5 is what we're dealing with there. And we have an equation to solve. And then again, we're going to cross multiply. So that gives me 240x minus 240 times 5 is 1200. 160x plus 160 times 5 is 800. So 80x minus 1200 equals 800. I'll go ahead and add the 1200 over. So 80x equals 2000. And I can divide by 80, and x equals 25. X equals 25. And so that means that the speed in still water is 25 miles per hour. All right, and there's a couple more examples, but I'll save those to do in class.